An Introduction to Microscopes, the CEU number 1. Be sure you've already taken an Introduction to Microscopes pretest found in the CEU number 1 materials folder before working through the following slides. Seeing the really important things that make our world. Before the 1960s, 1600s, most people had no idea that all life is composed of some sort of cell. Viruses are a unique form that requires greater time than can be given in this module. Many people believed in the process of spontaneous generation, that non living matter generated living organisms under the proper circumstances. Simply put, if one could not see a living thing, it was not there. In the mid 1600s, an Englishman by the name of Robert Hooke used microscopes to observe animal life, and he coined the terms cells due to the fact that a cork's cell structure reminded him of the cells in a monastery. Hooke authored a book called Micrographia, describing this unseen world. Shortly after Hooke's observations, a Dutchman by the name of Anton van Leeuwenhoek created a single lens microscope that could magnify between 200 and 300 times. He and others were amazed at the life they were seeing. He coined the term microbes, meaning small animals. He, however, kept his construction techniques to himself, often showing guests only average quality lenses in which to view his microbes. To learn more, research these two scientists and read about what they discovered. We're now going to use more modern microscopes in order to see this amazing world and to aid you in sharing this world with your students. First and easiest way to share is a magnifying glass. Most of these result in a magnification of 10 times or 10x. The best way to see one is to hold it near the eye, then bring the object up to your eye, stopping when it is in focus. These are great for looking at small, seen items like an insect, a leaf, or some lichen, but they do not expose the viewer to the microscopic world. Secondly is a magnifier known as a dissection scope. These are great to use to observe small items and will usually magnify up to 40x, the beginning of a microscope's viewing. This scope is easy to use and usually has 2 eyepieces, providing stereoscopic viewing. The light source is usually from the top or just room lighting, thus making the scope dependent on the reflection of light off of a surface. General steps for using a dissection scope include placing the item to be observed on a slide or petri dish. Put the dish under the scope, focus, and observe. If you're using a light, adjust the location and intensity. Focus by turning the focus wheel. Adjust magnification by changing the objective lens. Dissection scopes have their place in viewing 3D objects, but their magnifying power pales when compared to a compound microscope. First, we must identify the parts of the microscope and their uses. When carrying a microscope, one must use 2 hands, one under the neck and the other holding one under the base and the other holding the neck, aka arm. Always be careful of the power cord. Next, we will locate the light and the on-off switch. Some microscopes have a dimmer adjust the light, most do not. Some older scopes might have a mirror, in which case one must tilt the scope back and move the mirror, aiming it at a light, while looking through the eyepiece to see if the light is coming through the lens. Next, we will locate the important stage where the items we're looking at perform and the aperture wheel. The first is the stage, the black, usually flat surface that has 2 microscope slide clips. This usually travels up and down when focusing. Next, we will need to look under the stage and we will see the aperture wheel, a movable wheel that usually has 6 holes of various sizes. Many people will use the largest hole when trying to look at a slide. Wrong. Use one of the 2 smallest holes when you're using 40x or 100x. Think of it this way. On a dark night, looking into the car's headlights in front of you, can you really see any detail of someone standing in front of the car? No, too much light. Use one of the large holes when you're using 400x magnification or higher. Next, we come to the three objective lenses that are mounted on a turret, sometimes referred to as a nose piece, which allows the lenses to rotate. Some microscopes may have 2 or 4. These lenses usually have a 4 marked on the shortest lens, a 10 marked on the medium length lens, and a 40 on the longest lens. When you turn the lens, you will feel a click, which means it is in place. If the lens is not clicked in place, one will see either a completely black field or one with a black edge running through the field of view. The numbers are multiplied with the number found on the eyepiece to give you the total magnification that you are using. Usually the eyepiece is a 100 or a 10x, so 10x, the eyepiece, times 4x, the objective lens, gives a 40x magnification. 10x, the eyepiece, times 10x, the objective lens, gives a 100 times magnification. And a 10x eyepiece times 40x objective lens gives a 400x magnification. We will talk in more detail about the magnification in a few slides. After this, this is what we want a microscope to do.